So today we're looking at some logarithms, which if you remember from Algebra 2 are really just exponents. So if you think about like writing an exponential function with a certain base, like 64, you could write with base 2 as 2 to the 6th, 5 using base 5 is 5 to the 1st, 100 using base 10 is 10 to the 2nd, and so on and so forth. So the base of your exponential function is the number that's being raised to the power. So if you're like missing an exponent, typo, had to fix it, and you want to figure out what power you raise it to get that number, that's really all a logarithm is. So say, for example, you have like log base 2 of 8. That equals 3 because if you take 2, the base of your logarithm, to the third power, it equals 8. So a logarithm is equivalent to an exponential function. Base on the logarithm matches the base on your exponential function. The logarithm equals the power that you raise the base to get what's on the inside. So you can go back and forth between logarithmic form and exponential form. This is log base 2, so my exponential function also has to be base 2. 5 is what it is equal to, so that's like the power that I would raise 2 to get 32, which it's a true statement. You can check it and see if it's right. This is base 10, so 10 to the 0 equals 1. You can go the other direction and change something from exponential form to logarithmic form. So log base 1/5, because that's my base of my exponential, I know is going to equal my exponent of -3. So log base 1/5 of 125 equals -3. The base can be ugly, so it could be log base square root 3 of 9 is equal to 4. So switching back and forth between exponential and logarithmic form, hopefully not too bad. If you just want to evaluate the logarithm, that is you finding the power that you raise the base to get what's inside. So we're looking for like 2 to what power gets me 32. You could do this like your exponential equations that you solved yesterday. Be like, oh, well, 2 to the 5th is 32. So my power, or my logarithm, has to be equal to 5. This one's looking for 10 to what power would get you 1/10, 100th, 1/1000th. I would switch that to, I would switch that to a fraction and then think about, well, if I raised 10 to the third, that'd get me 1,000. So if I did 10 to the -3rd, that'd be 1/1000. I'm going to pause and let you guys try some. So solving an exponential equation, depending on what you're looking for, is really no different than what we just did. Here you're looking for 2 to what power gets you 32, so it's 5. Again, you're looking for the exponent on this one. It's going to be a little bit more complicated to solve because you're looking for 36 to what power gets you the square root of 6. Like yesterday, let's rewrite them with the same base. So like square root of 6 is 6 to the 1/2, 36 is 6 squared. Then we can multiply our exponents and have 2x equals 1/2. So that would mean that if you divide by 2, you're going to have x equals 1/4. Those were both looking for the exponent. Now you're looking for the base of your logarithm. So remember, it's like x raised to the power of 2 equals 4/25. You guys know how to solve that. Take the square root of both sides, which you're used to that being plus or minus 2/5, but in logarithmic equations, the base has to be a positive value. Logarithms are only defined if your base is positive. So you would disregard the negative and just have x equals positive 2/5. I will let you guys try this one. This is a little bit different because it's looking for what x is if you're raising 5 to the log base 5 of 13 power. So essentially, kind of what you want to think about is log base 5 of 13 is the power that you take 5 to in order to get 13. So I'm taking 5 to the power that I take 5 to get 13. Kind of a brain bender, I know. But if you take 5 to that power, you're going to get 13. Also, exponential functions and logarithms are inverses of one another, so this is probably easier to think about. If you have log base 2 and an exponential base 2, those are going to undo each other, and you will just get your original input back, which in this case, 2 raised to the log base 2 of 7 power just gets you 7.